Let's do a few challenging problems from pipes and systems. First one is a pipe which can fill a tank in 30 minutes is filling it. Due to opening an outlet pipe after half the tank is full, it took 15 more minutes to fill the tank. In how long will the outlet pipe empty the full tank? So here you have an inlet pipe which can fill the tank in 30 minutes. So in 1 minute, let me use a unitary method for solving this problem. If the inlet pipe takes 30 minutes to fill the tank, in 1 minute, so much of water will flow into the tank. So in how many minutes will half the tank be full? Half the tank will be full in 15 minutes. For filling the whole tank, it needs 30 minutes. So the inlet pipe will take 15 minutes to fill half the tank. I'm finding the half the tank because after the tank is half full, there is an outlet pipe that is also started working. We are opening an outlet pipe after half the tank is full. We don't know the rate of flow through the outlet pipe. So let me assume, let outlet pipe take n minutes to empty the full tank. See, in fact, this is what we are asked to find out. In how long will the outlet pipe empty the full tank? So we have assumed that it will take n minutes. Now come to the position where the tank is half full. Now let's look at the time taken by both the pipes together, inlet pipe and the outlet pipe, together to fill the remaining half of the tank. So what will be the rate of flow into the tank through the inlet pipe? That will still be the same, 1 by 30. And as per the assumption made here, what will be the outflow through the outlet pipe? That will be 1 by n. Because if it takes 10 minutes to empty a tank that's already full, 1 by n will be the quantity of water flowing per minute. So this is the inflow, this is the outflow. If you take the difference, you get the net flow. Rather, the amount of water filling the tank in 1 minute. Now this is the amount of water filling the tank in 1 minute. Now how long will it continue to do that? See, we are looking at the position of the next 50%, I mean the second 50%. Half the tank is already full. We are looking at how long will these two pipes take to fill the remaining part, rather the next half of the tank. What does the problem say? Due to opening an outlet pipe after half the tank, it took 15 more minutes. For filling the first half, it takes 15 minutes, as you can see. So for filling the remaining second half, it will take 15 more minutes, means totally it will take 30 minutes. And this is the rate of flow into the tank. This is the quantity of water falling into the tank in 1 minute. So in 30 minutes, so much water will be going into the tank. And what will be the total amount of water that will fall into the tank in 30 minutes? That will be half the tank, because the first half already filled up. We are not looking at that. So this is the way to work out the time taken by the two pipes together, I mean both the inlet and outlet together, to fill the tank, which is 30. And in 30 minutes, the second half of the tank is also getting filled up. So I am writing half. So in unitary method, I forgot to tell you something. We have done most of our problems using LCM method. So in unitary approach, the total work, or in this case the total volume of the tank, is taken to be 1 or unitary. This I have already explained in my basic video covering the basic concepts of time and work, which is given in the description below for your reference. Now this implies what? We got a simple equation in n, 1 by 30 minus 1 by n. Take 30 to the other side, you will get 30, which is 1 by 60. So take 1 minus n to the right side, and just for convenience, let me write it on the left side. So 1 by n on the right side, 1 minus 60 to the left side. So it becomes minus. Then I am changing the position. This on simplification, 1 by 60, which implies n is equal to 60. And what was n by the initial assumption we had made? The outlet pipe taking n minutes to empty the full tank, which we are sold to be 60 minutes. So this is the final answer to the question. In how long will the outlet pipe empty the full tank? In 60 minutes, it will empty the full tank. Let's do one more problem that is also a bit challenging before winding up today's session. The second question is this. Pipe A can fill a tank in 5 minutes. A second and third pipe with radii being 1/2 and 1/4 the size of the pipe A are also attached to the tank. Find the time taken by all the three pipes together to fill the tank. So totally we have three pipes. They name A as one of them. Let B and C be the other two pipes. A can fill the tank in 5 minutes, which means the rate of flow of A will be 1 by 5. What does that mean? In 1 minute, 1/5 of the tank will be filled up. Now, we need to find out the rates of flow of other two pipes, which are not directly given in the problem. Instead, they say the second pipe and third pipe have the radii being 1/2 and 1/4 the size of the pipe A. As you know, the bigger the cross-sectional area of a pipe, the more the water flowing through that pipe. Rather, the quantity of water flowing through a pipe will be dependent or proportional to the cross-sectional area of the pipe. And what will be the cross-section of a pipe? It will be a circle. Rate of flow, rather the quantity of water flowing through the pipe will be dependent or directly proportional to the area of the cross-section of a pipe. Which means the bigger the area, the more the rate of flow, or rather the more the quantity of water flowing through that. Now, from this, you can infer that ratio of the rates of flow of these three pipes, will be the same as ratio of their cross-sectional areas. Now, ratio of the cross-sectional areas you can easily find using the data given in the problem. Supposing R is the radius of pipe A, then radii of B and C will be what? 1/2 and 1/4 respectively. Now how do you find out the ratio of their cross-sectional areas? I mean cross-section of the pipe will be pi, R's cross-section will be circle. So this is the area of pipe A, then pipe B will be R by 2. Read this as 2. Then the other one will be R by 4 because this is 1/4. This is 1/2. Now this will be equal to pi gone, r square also will go. Finally it will come down to 1 is to 1 by 4 is to 1 by 60. So this is the ratio of the cross-sectional areas of the three pipes. Rather this will be the ratio rates of flow of A, B and C will be 1 is to 1 by 4 is to 1 by 16. But we know the rate of flow of A, which is 1 by 4. So combining this and this, you will get the rate of flow of the second pipe B as 1 by 4 into 1 by 5. And this will be 1 by 16 into 1 by 5. So these are the rates of flow, which you can simplify as this is 1 by 5, this is 1 by 20, this is 1 by 8. These are the rates of flow of A, B and C. Now we have found out the rates of flow of all the three pipes A, B, C attached to the tank. So what do you mean by rate of flow? In 1 minute, 1/5 of the tank will be filled up through A, whereas through B, 1/20th of the tank will be filled up, and through C, 1/80th of the tank will be filled up in 1 minute. Now, if you sum these rates of flow, you get this, and this is the quantity of water filling up the tank in 1 minute. You simplify this. 80 is the LCM. 16 plus 4 plus 1, 21 by 80. This is the quantity of water filling up the tank in 1 minute. The question is about what? Find the time taken by all the three pipes together to fill the tank. If this is the quantity of water filling up the tank in 1 minute, let's assume that the tank gets filled when all the three pipes are working together. Let N be the time, or rather the number of minutes taken by all the three pipes to fill the tank together. So 21 by 80 is the quantity of water flowing into the tank or filling up the tank in 1 minute. That into N will be what? Will be the total quantity of what? Filling up the tank. So which is assumed to be 1. I forgot to mention something. When you say, like I said, there are two approaches, LCM method and unitary approach. In this problem, we have used unitary approach. Go through my previous videos detailing the difference between unitary approach and LCM method. The link of the video is given in the description below for your reference. In unitary approach, we take the total volume of the tank as 1. It is based on this assumption, we get 1 by 5 as the rate of flow of pipe A. Rather, in 5 minutes, the tank gets filled up through pipe A, which means 1/5 of the tank will be filled up in 1 minute. That's based on the assumption of the volume of the tank being 1, which is what I am writing here. The total volume of the tank is assumed to be 1 in unitary approach. This implies what? N is equal to 80 by 21, which on simplification, so many minutes. If you want, you can further simplify depending on the options given in the problem. This will be 3 minutes, goes 63 times, 17 is the remainder. So you can write it as 317 divided by 21 minutes is the total time taken by the 3 pipes ABC to fill the tank. So we have worked out 2 problems in this session. Both the problems are a bit challenging. If there is any step you want me to further clarify, feel free to raise it in the comment section and I will address it there. See you guys in my next video where I will help you with smart solutions to tricky problems of this kind. Bye for now.